26% of Harley-Davidson owners experience catastrophic engine failure. But what if I told you that choosing the wrong Harley could drain your wallet faster than you can say Milwaukee? Engines that cost only $23 less to manufacture, but cause thousands in sudden destruction. In this video, we're counting down the 10 worst engines ever installed in Harley-Davidsons, ranked from bad to absolute disaster. And trust me, the top engine on our list earned Harley-Davidson a consumer fraud lawsuit. From plastic parts that self-destruct at 20,000 miles, to quality control meltdowns that created the oil leak stereotype, these engines define what happens when corporate cost-cutting meets engineering shortcuts. And here's the kicker. The #1 engine on our list contains a ticking time bomb that clogs your oil system with shredded plastic debris, leading to total engine destruction in minutes. Stay until the end, because this isn't just motorcycle history. It's data that could save you from buying a financial nightmare. Skip this, and you might invest your life savings into a bike that grenades itself on the highway. Number 10, the Revolution engine in the V-Rod, 2002 to 2017. The Revolution engine sounds impressive on paper. Liquid-cooled, dual overhead cam, developed with Porsche engineering, high-revving performance that pushed Harley into modern territory. But here's the problem that traditional Harley owners discovered too late. This engine transformed routine maintenance into dealer-only nightmares. The complexity of the DOHC liquid-cooled design made simple backyard fixes impossible. Tasks that took an afternoon on a big twin now required specialized tools and expert technicians, charging premium shop rates. The cooling system alone added layers of complexity that most Harley mechanics weren't equipped to handle. Valve adjustments became expensive ordeals instead of straightforward procedures. Every service interval meant higher costs and longer downtime. But the real failure wasn't mechanical. The Revolution engine committed the ultimate sin in Harley culture. It abandoned the classic rumble and feel that riders expected. The smooth, high-revving power delivery felt foreign to enthusiasts who wanted that traditional potato-potato sound. Liquid cooling replaced the distinctive air-cooled aesthetic that defined generations of Harleys. Number 9, the Revolution X engine in street models, 2014 to 2020. Harley-Davidson attempted to capture younger riders in global markets with the Street 500 and 750 models. The liquid-cooled Revolution X engine powered this strategic move into entry-level territory. The result damaged the brand more than it helped sales. Traditional Harley owners and dealers immediately criticized the perceived cheap quality and cut-rate components. The decision to manufacture these bikes overseas in India became a lightning rod for controversy. Core American customers felt the brand had betrayed its premium positioning to chase budget sales. The engine itself suffered from specific operational flaws that made the riding experience frustrating. The throttle response delivered what riders described as a disturbing lag and leap character. You'd twist the throttle and get hesitation, then sudden acceleration that felt unpredictable and unsafe. This uneven power delivery made the bikes difficult to ride smoothly in traffic or parking situations. New riders, the exact demographic Harley targeted, found the throttle behavior unsettling and difficult to master. Experienced riders simply refused to accept this level of refinement from a brand that charged premium prices. Number 8. Early Panhead engines, 1948 to 1955. The Panhead engine marked a major technological advancement for Harley-Davidson. Overhead valves with enclosed rocker arms replaced the previous knucklehead design. The distinctive pan-shaped valve covers gave the engine its name and promised better performance. But the early years created a lasting reputation problem. Those first 7 years of Panhead production struggled with a fundamental engineering challenge: sealing the top end. The aluminum rocker covers and pushrod tubes simply wouldn't stop weeping oil. This wasn't occasional seepage, but chronic, visible leaking that marked every parking spot. The root cause involved thermal expansion differences between aluminum cylinder heads and iron components. The sealing technology of that era couldn't handle these expansion rates effectively. As the engine heated and cooled through normal operation, The seals failed repeatedly. This created the cultural stereotype that all Harleys leak oil and mark their territory. Jokes about following the oil trail home or needing drip pans became standard ammunition for critics. The Panhead earned this reputation honestly through years of persistent seepage. Owners who wanted a dry Panhead faced expensive modifications. Aftermarket solutions and specialized parts became necessities rather than options. Even with intensive work, achieving reliable sealing required knowledge and parts that weren't readily available to average mechanics. Number 7. Twin Cam 88 Launch Defect, 1999 to 2000. The first twin cam 88 engines rolled out with more than just the tensioner problems we'll discuss later. The very earliest models contained a critical bearing flaw that threatened sudden engine destruction. Models sold in 1999 and early 2000 used a rear cam bearing design that failed prematurely. This wasn't a gradual wear issue or something that gave warning signs. The bearing could deteriorate and cause total engine failure while riding, potentially leaving owners stranded or worse. The severity forced Harley Davidson to acknowledge the problem officially. In January 2001, the company sent warning letters to owners admitting that a small number of TC-88 engines contained this defect. They offered a special extended warranty, 5 years or 50,000 miles, specifically covering this bearing. But an extended warranty didn't change the fact that engines were already failing in the field. Harley made a running change to the bearing design partway through the 2000 model year, meaning some bikes got the fixed bearing and others didn't. Owners needed to check individual build dates to determine if their specific bike was affected. The company offered a fix kit for affected early models, but this solution came at considerable cost. Replacing a rear cam bearing requires significant engine disassembly and labor time. Many owners faced 4-figure repair bills to correct a manufacturing defect they didn't cause. Number 6. Evolution Engine, 1984 to 1998. The Evolution engine gets credit for saving Harley Davidson after the AMF disaster years. Improved durability over the Shovelhead brought reliability back to acceptable levels. But the Evo Big Twin carried its own persistent flaw that frustrated owners throughout its production run. Cylinder-based gaskets failed repeatedly on early to mid-production Evolution engines. Oil weeping or full leaking from where the cylinder meets the crankcase became a common and expected problem. Park the bike and return to find fresh oil underneath the cylinders. This wasn't just about replacing a gasket. Mechanics discovered that simply installing a new gasket rarely solved the problem permanently. The issue ran deeper into manufacturing tolerances and surface preparation. The cylinder base mounting surface often wasn't perfectly perpendicular to the bore. Proper repair required machining the cylinder base to create a truly flat, perpendicular surface. Only then could technicians install advanced multi-layer steel gaskets or Cometic EST gaskets that actually sealed properly. This level of work meant serious labor costs and machine shop time. For owners trying to budget repair their bikes, the cylinder-based gasket became a recurring expense. Install a standard gasket without machining the surface, and the leak would return within months or even weeks. The temporary fix never lasted, leading to repeated repairs and mounting frustration. The gasket leak wasn't catastrophic like oil pump failures or bearing destructions. Your engine didn't suddenly grenade on the highway, but the constant seepage and repeated repair attempts made ownership expensive and annoying. Every parking spot got marked, and every ride meant checking oil levels. Number 5. Ironhead Sportster, 1957 to 1985. The Ironhead Sportster maintained essentially the same design for 3 decades. This longevity came at a cost to riders who experienced the raw reality of this engine platform. 2 specific issues made Ironhead ownership a physically demanding and mechanically intensive experience. First, the vibration problem earned the engine its nickname, the vibrator. The rigid mounting system bolted the engine directly to the frame with no rubber isolation. Every combustion pulse, every mechanical vibration transmitted straight into the chassis and through to the rider. Long rides on an Ironhead meant numb hands, tingling arms, and physical fatigue that went beyond normal riding tiredness. The vibration loosened bolts, rattled components, and created a harsh riding experience that tested endurance. Mirrors became useless blur makers at highway speeds. Second, the iron head consumed oil at rates that seem impossible by modern standards. Heavy and persistent oil consumption resulted from design tolerances and sealing methods that simply couldn't contain the lubricant effectively. The engine burned oil through combustion and wept it from seals simultaneously. Harley Davidson actually published technical guidance suggesting that consuming 1 quart of oil every 1,500 miles fell within acceptable parameters for certain ironhead models. Think about that. Adding oil every few tanks of gas wasn't considered a defect but normal operation. Models from the 1980s gained particular notoriety as especially unreliable examples within an already problematic line. These later ironheads combined maximum vibration with maximum oil consumption, creating the worst possible ownership experience. Riders needed to carry spare oil and check levels constantly. Long trips meant planning oil stops along with fuel stops. The mechanical simplicity that made ironheads easy to work on became a necessity because they required constant attention. Number 4. AMF-era Shovelhead, 1970 to 1981. The Shovelhead engine design itself proved fundamentally sound and durable. Built on the reliable Panhead bottom end, the mechanical engineering was solid. But corporate ownership decisions transformed a good engine into a nightmare of unreliability through systematic quality destruction. When American Machine and Foundry purchased Harley Davidson in 1969, profit pressure immediately overwhelmed engineering standards. AMF management pushed aggressive cost-cutting that cascaded through every aspect of manufacturing. The Shovelhead became the victim of these decisions. Cheaper parts flooded the supply chain, often sourced from overseas manufacturers with lower quality standards. Components that previously met strict specifications got replaced with barely acceptable alternatives that saved pennies per unit. Labor disputes and union conflicts during this turbulent period further disrupted production quality. Quality control effectively collapsed under these combined pressures. Engines left the factory with mismatched tolerances, improperly torqued fasteners, and components that barely met minimum specifications. The result was chronic, widespread oil leaking from seals and gaskets across the entire engine. The AMF Shovelhead became the definitive unreliable oil leak in motorcycle history. Every gasket wept, every seal failed, every surface junction marked territory. Riders needed drip pans everywhere they parked. Fresh oil stains appeared after every ride. These weren't isolated cases or random quality escapes. The oil leak problem affected virtually every AMF-era Shovelhead, creating a systemic reliability disaster that damaged Harley's reputation for decades. The phrase about Harleys marking their territory became accepted truth. Beyond leaks, overall build quality suffered in ways that affected reliability across every system. Electrical problems, carburetor issues, transmission defects, every component felt the impact of cost-cutting and quality decline. Owners needed mechanical skills just to keep their bikes running. The AMF era created lasting reputational damage that associated Harley Davidson with shoddy manufacturing and mandatory constant maintenance. Even after the 1981 management buyout ended AMF ownership, the company spent years rebuilding credibility destroyed during this period. Now we need to talk about something important. If you're finding this information valuable and want to make sure you catch more deep dives into Harley history, hit that subscribe button. We're just getting into the really catastrophic failures, and you don't want to miss what's coming next. Number 3, Milwaukee-Eight Generation 1, 2017 to 2019. Harley Davidson launched the Milwaukee-Eight engine in 2017 as the successor to the twin-cam platform. This new big twin promised modern performance and improved reliability. Instead, the first generation delivered a critical flaw that caused overheating and potential engine damage. The oil pump design in 2017 through 2019 Milwaukee-Eight engines couldn't properly scavenge oil from the crankcase during certain conditions. This allowed oil to accumulate in the crankcase instead of returning to the oil tank, a condition called sumping. When oil sumps in the crankcase, several problems cascade simultaneously. The rotating crankshaft starts whipping through accumulated oil, creating aeration and foam. This foamy oil can't lubricate effectively, and the aeration reduces oil flow throughout the system. Simultaneously, the oil level in the oil tank drops because oil is trapped in the crankcase. Riders checking their oil levels see low readings and add more oil, not realizing the missing oil is sumped in the engine. This leads to overfilling that makes the problem worse. The sumping issue became particularly severe during hot weather riding or extended highway speeds. Engines began overheating as oil circulation degraded. Some riders reported excessive heat radiating from the engine that made the bike uncomfortable or dangerous to ride. Harley Davidson eventually acknowledged the problem and redesigned the oil pump for 2020 model year bikes. The updated pump featured improved scavenging capability that prevented oil accumulation. But owners of 2017 to 2019 bikes were left with engines containing the defective pump design. The fix requires replacing the oil pump with either the updated OEM pump or aftermarket alternatives with better scavenging. This repair isn't cheap. Labor costs for accessing the oil pump add up quickly, and the parts themselves run several $100s. For owners who experienced overheating from oil sumping, the damage may extend beyond just needing a pump replacement. Prolonged operation with degraded oil flow and elevated temperatures can damage bearings, cylinders, and other internal components requiring more extensive repairs. Number 2. Twin Cam 96 and 103, 2007 to 2016. The Twin Cam platform continued beyond the early tensioner problems with a different critical flaw in later versions. The 96 and 103 cubic inch variants introduced in 2007 featured a primary compensator design that self-destructed with alarming regularity. The compensator sits between the engine and transmission, designed to absorb drivetrain shock and smooth power delivery. The factory compensator used in these twin cam engines featured a fundamentally weak design that couldn't survive normal use. The compensator assembly began failing at various mileage points, sometimes as early as 10,000 miles. When it failed, the internal spring mechanism would break apart, causing catastrophic noise and vibration. The distinctive sound became known among Harley mechanics, a horrible grinding or rattling from the primary case. But the compensator failure didn't just affect the compensator itself. The spring debris and metal fragments contaminated the primary case, often damaging the primary chain and other components. What started as a compensator problem quickly escalated into extensive primary drive repairs. Riders reported violent shaking and noise that made the bike nearly unrideable when the compensator failed. Some failures were so severe they left owners stranded, unable to shift or ride the motorcycle at all. The primary case needed to be opened, cleaned, and multiple components replaced. The repair process requires specialized tools and knowledge. A sprocket locking tool, compensator unloader tool, and proper torque specifications are essential. Many home mechanics lack these tools, forcing owners to pay dealer labor rates for extensive repairs. Aftermarket companies developed heavy-duty compensator replacements and even compensator elimination kits that remove the factory design entirely. These solutions work effectively, but represent additional costs to fix a design that should have worked properly from the factory. The compensator problem affected virtually all 2007 to 2016 Twin Cam 96 and 103 engines. Some owners got lucky and experienced later failures, but the question wasn't if the compensator would fail, but when. This systemic design weakness created yet another expensive reliability problem for twin cam owners. Number 1. Twin Cam 88 early years, 1999 to 2006. The absolute worst engine ever installed in a Harley Davidson is the early Twin Cam 88 from 1999 through 2006. This engine earned the top spot through a combination of catastrophic failure mechanism, widespread impact, and corporate negligence that resulted in a consumer fraud lawsuit. The fundamental flaw lived in the cam chain tensioners. These spring-loaded tensioners used nylon or plastic composite shoes to guide the timing chains. The material couldn't survive the engine's operating environment, failing rapidly and prematurely around 20,000 to 30,000 miles. When the plastic tensioner shoes wear through and shred, the debris enters the oil circulation system. Think about what happens next. Tiny fragments of plastic flow through the oil passages, heading directly toward the narrow inlets of the rotary gear oil pump. The microscopic pump inlets clog with plastic debris, immediately cutting off oil flow to critical engine components. Total oil starvation follows within minutes or even seconds. Bearings run dry, cylinder walls lose lubrication, and metal-on-metal contact begins throughout the engine. The destruction happens fast and completely. One moment you're riding normally, the next moment you hear terrible noises as the engine tears itself apart from lack of lubrication. Connecting rods, bearings, cylinder walls, pistons, everything fails simultaneously once oil flow stops. Mechanics describe this as a ticking clock awaiting failure. Every mile on an early twin-cam 88 with original tensioners moves closer to catastrophic destruction. The failure isn't gradual or gentle. When it happens, you're looking at complete engine replacement or major rebuild. The financial devastation compounds the mechanical destruction. A full engine rebuild or replacement costs thousands of dollars in parts and labor. Many riders discover this failure while far from home, adding towing costs and travel disruption to the repair bill. But here's where this gets truly outrageous. A consumer fraud class action lawsuit alleged that Harley Davidson knew about the tensioner failure propensity before widespread field failures occurred. The company allegedly chose to save just $23 per motorcycle rather than installing reliable components. $23. That's the reported cost difference between the plastic tensioners that self-destruct and proper hydraulic tensioners that work reliably. The company saved $23 per bike and created thousands of dollars in owner repair costs when the defective parts failed. The lawsuit claims Harley Davidson prioritized minimal manufacturing savings over customer safety and reliability. This wasn't an unknown defect that appeared unexpectedly in the field. Internal knowledge of the problem allegedly existed before the engines reached customers. For owners of 1999 through 2006 twin-cam 88 models, immediate inspection and replacement of the tensioners is mandatory preventative maintenance. The upgrade involves installing hydraulic tensioner plate kits like those used on later twin-cam 96 engines or aftermarket alternatives. These engine failures reveal patterns that go beyond mechanical problems. But even the worst engines look normal compared to what Harley created in their weirdest moments. Check out our video on the 11 weirdest Harley Davidson motorcycles of all time to see designs that confused everyone.